So mass spectrometry, and these are MCQs, the easy ones. So what were you saying? The answer to question number one was?
D,
And why do you think that is correct?
because most stable and 100% peak.
Okay, you're right with most stable part, but this is not the 100% peak. This is the tallest peak, however. You can say most intense, strongest, tallest. Either of these words are fine, but not 100%. Okay. Question number two,
Yeah.
and yes, you were right.
B,
B, as in beta.
yes.
Think again. Do you think the M over E value for B would be 55? Have you tried calculating it?
It is 55. 56 आ रहा है, so 56 minus 155.
Why minus 1? It just lost
Plus,
an electron, not an entire proton or neutron. Losing an electron cannot be calculated as a loss in mass. You know how light the electron is in comparison to a proton or a neutron. Don't forget the numbers 18364, 1842 times lighter, which is a big deal.
yes. C,
C. Now, why is C correct?
12 into 4 plus 7.
Perfect. The question was really simple. It falls under the easy category because of the fact that among all of the answers, only C is the one which has 55 M over E value. The rest have different M over E values. If you calculate A, that is 58. If you calculate B, which you did, I never did, by the way, was 56. So yeah, they're different. Okay, moving on. Number three.
Um, D,
And why D?
I just think D is correct.
Come on, you must have a logic. You're not going to go for a wild guess. Or are you?
I am actually.
Okay, okay, fine, fine. Now let me tell you the lowest mass, or the one with the highest charge, show us the greatest extent of deflection. So under all the cases, the lowest mass would be in a 35, but that brings us to both B and D. But the highest charge since has the greatest deflection, so B is not the right answer. D is Na35 2 plus charge. Good. Okay. Question 4. Sometimes the hunch we have in us may lead to the right answer, but that happens rarely. So instead of just believing in the hunch, it's better to go with logic.
Yes, sir. Option D is not correct. Option C is not correct.
Option B is not correct. Option C is not correct. So which is the correct one?
Option C and D are not correct.
Oh, C and D are not correct, which means you're going to pick something out of A and B. Go ahead.
Yes. Mm, it's not correct. B.
No, not correct. B is
It's
not the
not correct.
answer. Actually,
A.
they both have different function groups. So different fragmentation pattern is something that should be a must. So B is actually correct, and B being correct will not be the right option because the right option has to be an incorrect statement. So you're finally left
A.
with A, which leaves us A as an answer. But why is A an incorrect statement being the correct answer?
Molecular ion peaks at same mass to charge ratio.
Would be the correct line, right? If we talk about molecular ion peaks, then you'd notice that both of them are C3H6O. So the molecular ion peak for both of them, C3H6O positive, would be the same for this one as well as for this one. So this is the only statement which is not correct. Because if it would be same, only then it would be a correct statement. Being different means it's not correct. The rest are fine. Notice they will have different fragmentation patterns, of course. One of them acts like this and this, right? The other one acts like this and this. So of course, they'll have different fragmentation patterns. And since they have different fragmentation patterns, they will have a different fingerprint region. One of them is aldehyde, one of them is ketone, right? And absorption in the infrared spectrum would be different due to the carbonyl group. Yeah, the carbonyl group is present in both cases, but it's not just the carbonyl group, it's about the whole functional group that we talk about in both the cases. So these three statements are actually correct. This is the only one which was incorrect, and this is the word. We figured it out. So I hope the whole MCQ makes sense to you, right?
Yes, sir.
Good. Question number 5. Definitely is an easy question, but requires some calculation. Go ahead, take your time.
C.
Okay, good. You were quick. Well done. So I guess you used the formula we studied back in IGCSE, and you took them all, the mass of the isotope multiplied by abundance. Which number you divided it with?
100.
100. Did you try to add the percentage abundance and calculate whether it was equal to 100 or not?
No, but I think it is. I think it is equal to 100.
Because it might be equal to 99.9. It might be equal to simply 99 and not 100. You're lucky
It's equal
because
to 100.
you're lucky because the answers are given in such a way that there is no uh, difference except for C and D, which is a zero point 0.2 difference. So that actually saved you from a whole big mistake. But try to also add these. You might end up on a different number than 100. Okay. And don't forget
Yeah.
that the specific point that all of them are given up to two decimal places, and he required an answer to one decimal place, which definitely means that we will probably need to round off at the end. But well done. C was the correct answer. Moving on, question 6.
C.
C, good. Again, you're quick and correct. This time I'm not going to ask any questions because you already knew about the 100 portion. So 7. Again, a similar question. And one of my most favorite examples. So you're probably done with the example before, because when I usually teach, I tend to go with the example of neon most of the time.
B.
As in beta or D as in door?
Beta.
Beta. Perfect. Moving on. You're quick with these. That's good. Question 8.
It could either be B or C.
Pick one.
But it says incorrect. So option A.
No, option A seems to be perfectly fine to me. Pretty simple of calculation.
Um,
It's extremely simple. 35, 35, 35. I mean, 35 into 3, 105. 105 plus 14, 119. It's the simplest calculation there is.
okay.
This I considered as the incorrect answer because we are supposed to find an incorrect option as a correct answer. So this never seemed to be the answer to me.
Oh, okay. 21. Option D.
D. Why?
37 into 2 gives us 74, and then 74 plus 14 gives us 88.
Right, and this is 125. So this is the only one incorrect. For the rest of them, whenever you calculate them, that's fine. It would have been correct if this was 3, right? This was then
Yeah.
been 111. 111 plus 14 would be 125. This would then have been correct. But since this is 2, we immediately found out that it was not the correct calculation, hence the correct answer. Question number 9. I'm going to zoom out a little bit more so that you can see the whole question. There you go.
I think B.
Why B?
Hmm. It's you could think of it as 90:10, like 9:1. Actually, C.
Good. How did you come up with C?
28 into 80 plus 29 into 10 and 30 into 10. So like estimates.
But don't you think 29 is a little bit bigger than 30?
Yeah,
But closest idea wins.
um,
Good. Good. I am happy with the approach. Even if there is a minor difference, you're still doing it correctly. Your answer was C, right?
yes, sir.
Good. Good. Well done. I appreciate it. Now, if you get a question like this, how are you going to do it as quick as possible? The first method is obviously going with prediction, like you just did 80 for 28, 8, 10 for 29, 10 for 30. But since the answers weren't close enough, it was really easier for you to pick either something between B and C since they're far away, so it gives you an edge. But what if the answers are too close and you need something more precise or accurate? What would you do then?
Um, Ratio probably.
How would you take ratios? If you're going to do something based on prediction, you already applied that. Come up with a different idea. What if you can't predict? What would you do then?
I don't know, sir.
Oh, come on, that's really easy. Okay, learn to use the tools effectively that you have in exams. One of the tools that you have in exams with you is a part of your geometry box is the scale. Go for the scale. The scale can really help you to calculate its length. So is the length of this one. So is the length of this one, right? Calculate all these lengths. I'm going to do a little bit of calculation for you to make it easier for you. So this is A, this is B, this is C. So A plus B plus C, right? And you get a total. It's better to divide that by 100. If you need something really accurate, divide that by 100 and now you have 100 parts. Multiply A with those, that, B with that, C with that, and you get your numbers. Even if you don't do that, you pick this one and multiply with this one with this one, this one with this one. Let's not divide it by 100 even. Find out A, B, and C. Okay, A into 28 plus B into 29 plus C into 30 divided by A plus B plus C is equal multiplied by 100, right? Do we multiply it by 100? No, we don't get an answer in percentage. So no multiplication by 100 needed. There you go.
Okay,
Get the
sir.
point? So you
Yes, sir.
simply need to measure them. Don't even divide them by them 100. That is for a too accurate enough an answer, and that would simply waste time in exams for you. This is a much easier way to do it. Okay,
Yes, sir.
good. Good. Now, but the idea of prediction works well if the answers have bigger differences in them. The last question, question number 10 for easy part. And it's better to do all of your calculation in millimeters, not in centimeters, not in inches. That won't help. Millimeters is a much better way to do it.
D.
So question 10, I never read the question. Just a minute. Cannot be obtained from an infrared spectrum. This is the, okay, this is definitely not mass spectrometry. No, this is not the right answer. Remember, cannot be obtained. D,
A.
something that is going to get us to it, can be obtained. A, right. We can't get molecular mass from infrared spectrum. We can get the presence of bonds because different bonds resonate at different frequencies, gives us, or the wave numbers gives us an idea which bond is, what type of bond is probably present. So B is true, C is true. When we compare it with other spectra like NMR, like mass spectrometry and other spectra, we may have some other types too. It can really easily give us the idea or the identity of the compound, but A, molecular mass alone from infrared spectrum, that's not possible. That's why we take help of other spectra. So A is the correct answer. Good. Okay. This gets us to second part, medium questions. Question one. This definitely requires some good working.
Option B तो नहीं है. I think D भी नहीं है. Could be A or C.
Pick one.
Um,
Remember, it's about not likely to have a fragment.
C.
You pick C.
1 second. Option D.
B is in beta.
D. Door.
Door. Why? First, you're correct. Well done. Why?
Because I don't know how to explain it, but CH3, CH2, CH, if you just fragment it and separate them, so the MR won't give us 43.
Then why are you saying you don't know how to explain it? You explain it in such a perfect way. That's the perfect explanation. Come on. Okay, take a look at this. If we fragment this part, right, this would give you 43. If I fragment this part, 3 carbons and 7 hydrogen is a perfect 43, right? 3 carbon and 7 hydrogen is a perfect 43 again, right? So in every case, I am getting 43, but in this case, we won't be able to get to that. This would stop at 42. And every time I try to fragment a portion out of it, I am not able to get 43. Let's say, suppose if I take this one out and if I try to fragment this part, this would again be 42. I really can't get 43 out of it. And you explain the same thing. And that's what we need to do in fragmentation questions. Okay, question number 2. And well done.
Which of the following compounds plays not likely to have a fragment? Right, 43.
A much similar question. The similarity is exquisitely big. So it's the same 43, it's the same phenomenon, it's even the same fragmentation pattern. This should be extremely easy.
It's either A or B.
Think again. And pick one, of course. You're right with this. I'm not saying you're wrong, but you need to pick one. I guess you easily did that for C and D because if I fragment this part, this is exactly 43 as we have previously talked about. So is this one, CH3, CH2, CH2 is exactly 43. So it really can't be C and D. What about A and B? Because one of this is definitely having 43 in it.
A.
Good, perfect. A is the correct answer. because if I fragment this out of B, again, it would be 43. Whatever I do to this one, I don't end up at 43. If I try to take this part out, not 43, of course, right? If I try to take this part out, not 43, of course, I can't really take CO and CH3 out of it, which is not possible as a fragment in this case, of course. So question number question number three.
Yeah, I don't get the question. Like chlorine has only two isotopes and hydrogen and carbon as one.
Okay, let's relate it to the previous question. Remember, there was a question in which we had NCl3 and we
Yes.
took four scenarios out of it, and all of the Cl3 are 35. There was another scenario that two of the Cl are 35, while one of the Cl is 37. There was another scenario that two of the Cl are 37, but one of them is 35, right? And last scenario, which was wrong and turned out to be the answer, was that all three Cl are 37. So these are the possibilities. This is the possibility when chlorine has two isotopes and nitrogen only has one. Now consider carbon has one isotope, hydrogen has one isotope, and we have two isotopes for chlorine. How many possible scenarios or arrangements like this can you make out of this molecule? Remember, carbon has only one isotope, so there would be no difference in C4. Hydrogen has only one, there is no difference in H6. The only difference we can bring about is in Cl4, where there are a total of two isotopes. Okay, so you
Two.
can start it like this: C4H6, all four Cl are 35. Then the next one, in which how many 35s are there, how many 37s are there, then all 37s. In this way, keep on calculating the scenarios, and then as per the number of scenarios, pick a number from here.
All right, sir.
And
It's
2
either
is
two or four.
definitely not the answer.
Then four.
No. Remember, I came up with four scenarios. If there were three chlorine atoms, there are four chlorine atoms in this case. Definitely the scenario is bigger. The only possible
Five.
answer would be A. But let me clarify. C4H6Cl35, C4H6. Now there are three 35 type isotopes, and there is only one which is 37. Make sense? The opposite can
Yes.
happen. C4H6. There is one 35 type, and there are three 37 types, right? And then there is C4H6 when there is an equal chance of two Cl types of 35 isotope and two Cl types of 37 isotopes. Or there can be a compound with all four Cl to be 37 isotopes. So 1, 2, 3, 4, 5. If there were three, all three can be 35 or all three can be 37. Or two of them can be 35, one can be 37, or two can be 37, one can be 35. We can do the same with four chlorine atoms. It's just that the calculation gets a little bigger. Make sense?
Yes, sir.
Good, good. Uh, you need to try these kind of questions more so that you can come up with the possible scenarios. Okay, next one. Question number 4.
Main two isotopes. 79 is reaction pattern. B.
B, well done. Remember, since the electronic configuration of all isotopes is same, so A can't be correct. Since the proton number is also same, so C can't be correct. And since I've already spoken about electronic configuration, first ionization energy, number of protons cannot be correct. The only answer B, beta, is correct because when we add C3H7, which we have calculated in the previous questions to be 43, to 79, the answer comes out to be 122. When we do the same with 81, the answer comes out to be 124. So yeah, there would be two molecular ions C with 122 and 124, and of course, they're going to be of the same height as their 50-50%. Okay, so B is correct. Moving on. Let's clear this one up. Question number 5.
Which alcohol is likely to have a fragment lying at 31 in its mass spectrum? A.
Good. And what's the fragmented part that we are talking about?
CH2OH.
Perfect. OH is 17, CH2 is 14, the total is 31, which we can see over here. We can't really take out CH2 out of here or out of here, not possible. Out of here or out of here, not possible. Here we might have a possibility of these CH2 and OH, but since this fragmentation chances are too low, so A is the correct answer. I hope you get the point. We can't just simply keep breaking the molecules wherever we'd like to. That's not how it works. So question number 6.
Singly charged peak at 29. सर प्रोपेनॉल का फॉर्मूला क्या था?
It's an aldehyde, so of course CH3, CH2, CH3, CH2, and CHO. You may write it like this, or you may really draw it like this. So it's entirely up to you.
I think B, beta.
How come?
Propanol is CHO29 and propanol is also CHO29.
And which fragmented part are we talking about in case of 29, which is
CHO.
possible in both ones?
CHO.
Would you get CHO in propanone? Okay, you will get a CHO over here. Will you get a CH over O over here, which is something like this? This is 3, this is C11O, and this is CH3. Will you get a CO and H along with it in the fragmentation of propanone? I don't think so.
Yeah.
So,
So, mm,
is it possible that we might be talking about some other fragmentation?
yeah. Plus 32. Thirty. Mm, 41.
Come on, this should be easy.
C.
No. If you're going to take CHO out of propanol, how would you take it out of propan-2-ol? And since I've already mentioned, it might be some other fragmented part other than CHO.
CH3.
CH2, CH3, perfect. Okay, like this part is 29 in its M over E value. This part is also 29 in M over E value. So if this gets a C29, this may also get a 29. This may get a 29. This will not get a 29. This can get a 29. This cannot get a 29. Both of them, well, this one can. This one can get a 29. That's how it works. The only pair is because there is a CH3, CH2, which is C2H5 positive in this one, as well as in this one, or this one, or this one, or this one, but not here because it's CH3CH, not CH2, and that's how we get to ol. I hope that clarifies it. Does it?
Yes, sir.
Good. Moving on. Let's see question number 7. Definitely not mass spectrometry. If you'd like to do the question, we can stay. Otherwise, I can skip this and get to mass spectrometry.
I'm sure let's just do mass spectrometry.
Okay. Then we have question number 8 for mass spectrometry.
We got 57.
This should be easy.
C.
Repeat.
C.
What are you saying? It's really difficult for me to understand whether you're saying B, D, or C. Say the whole
C.
word.
3-methylbutanone.
Okay, C. All right. Yes, you're correct. Okay, I have hope you have figured it out that this is the whole fragment which is possible in this one, possible in this one in both the ways, this one or this one, possible in this one or from this side, but it's not possible in this one. So C was the right answer. Okay, another question like the one you were previously getting confused at, but this is an easier form of that question. Go ahead.
I think 3. I'm just assuming.
Come on, calculate it. Okay, go ahead and calculate it for me. First of all, well
Um,
done. Your assumptions are going really well today. But go ahead with the calculations. Make a
I
logic out of it.
how the last time we did the question, it was an NCl3 तो 4 थे और फिर जब 4 थे तो 5 थे तो ये 2 है तो 3 होंगे.
Okay. That's a good permutation guess, but you're not a math student, you're a bio student. I don't know how your permutation guessing is going so good, but since there are two CLs, so both of them can be 35 or both of them can be 37. Easy chance. All right, one of them can be 35 and one of them can be 37. That's how it works. So there are a total of three. Make sense?
Yes, sir.
Now, my question to you is if we take all of these three peaks, what would be the ratio between the peak height? Something we've studied in the book.
3:1.
These are two chlorine atoms per molecule.
Oh, sorry. 2. 7.
It's not a question of two that you give me an answer like this. It's a question of three. So your answer is supposed to be like this. It's not 3
9 ratio
ratio 1. That's not how it works.
9:6:1.
Perfect. 9 ratio 6 ratio 1. Right? So this gotta be 9, this going to be 1, and this is going to be 6. Why? Because there are two possibilities. Actually, this is going to be a possibility of 3 plus 3. One possibility is this, and one possibility is this if the compound contains other elements too. So 3 plus 3, that's how it's 6. That's what I explained you in the previous sitting. Okay, last question for this one. Then we're going to go for hard questions. Question number 10.
Which of the following statements not mass spectrum of CH3 beyond? D.
Good. Well done. Equal size because there are 50-50%, 94 when BR is 79, 96 when BR is 81. 94 and 96 are correct over here, but this ratio belongs to CL and not to BR. 95 is totally wrong because you can't really use AR in case of mass spectrometry. These are individual isotopes and they will have their own isotopic masses. You can't really use the relative mass in there. And 43, there would be no peak around 43. Can be a peak around 15, understandable, and there can be a peak at 94 and 96. But why would there be a peak at 44? What's 44 in there? Nothing. I hope that clarifies the whole thing. Okay, so let's stop with this. And the last one, hard question. Let's see how the billionaire is going to do in these type of questions. Starting with question number one, let me zoom out a little bit. I'm going to zoom out more because this is a big question. There you go.
Which species is most likely to cause the peak at 28? Um,
Let's try to do them a little quickly. I'm not going to wind up the call if you're not busy, and I really want to finish all the questions in this sitting.
okay, sir. Mm, 56. C.
Perfect. Was it a hunch or logic?
Both, I guess.
Okay, good. Well, that's right. Good.
Two stable isotopes of bromine have relative
Question
masses
two.
79, which is the correct pattern of peaks. 79 and 81. And molecular peak is two stable isotopes. Two. No. Two stable isotopes. Mm, D.
By D.
Two isotopes. So 159 and 161. Then the molecular peak at 160.
Good.
And then equal heights.
Good. But what about the bigger one right in the center of them?
No, no.
You're
No.
going good, fine. D is correct. I don't say that it's incorrect. I'm asking you the logic of 160. You're also right about 159 and 161 peak that they are going to be of the equal height. That's perfectly good. But why we have a much higher peak at 160? That's my only question. For the rest, you have
It's the
explained it all, so that's perfectly good.
that's the molecular peak.
Do you remember the ratio if there are two bromine atoms in a molecule? The triple
1 ratio.
ratio.
1:2:1.
This is 1 ratio, 2 ratio, 1. This is
Yeah.
perfectly good of a ratio in case of the masses. There is 1 ratio because the bromine molecule can entirely be made of 79. That's ratio 1. Then there is another ratio 1 if the entire bromine molecule is made out of 81 isotopes. This ratio is 2. Why? Because it's 1 plus 1. One chance is that one bromine is made out of 79 and one bromine is made out of 81. And again, the opposite configuration. The first one is made out of 81 and the second one is made out of 79. In both the cases, the answer turns out to be 160. So 1 plus 1, double height. Again, this is 79 and this is 81. So for this part is correct in all these three. This is wrong. There can't be a single peak because there are two molecules. Wrong. There can't be peaks with 1:1:2. That is also wrong. This is the only one that is correct. Perfectly correct from start to end. I
Yes,
hope
sir.
this makes sense.
Yes.
This question actually clarifies our idea for the molecular systems which consist of two halogen atoms. Okay, question number 3. And really, compound B, compound C. You might need to scroll back and forth. Okay, this is compound A. The biggest peak over here is at 45, but the molecular peak is at 59. Keep that in mind because that's what we are going to work with. The biggest peak is at 56. The molecular peak, however, is at 57. And the molecular peak seems to be at 60, while the biggest peak, base peak, is at 59. No, there are smaller peaks too. Sorry, I missed out the smaller peaks. '75. This is 74. 70, 71, 72, 73, 74. 73 and 74. 73 and 74 and 75. The smaller peaks at the end of it. No, this is also 74. This is not 75. I am mistaken. Wait a second, let me calculate it. This is 70, this is 71, 72, 73, 74.
Then A.
This is a clear hint. Yes, A. You're right. Because they all don't show a molecular peak at 73, not possible. Since there are higher, bigger peaks at 74, so 73 peak would not count. 13 would not count. So this is the only answer. That's correct. Okay, moving on. Let's see what we have next. Question number 4. This is not here. Yeah. This is IR. Let's skip it. Let's stick to mass spectrometry for the time. This is again IR. You may practice them later. If you have any questions from IR, you can ask me afterwards, but let's stick to this. Okay, question number 7.
Fluorine exists two isotopes. These are the following molecular and the mass spectrum of Cl2 is correct.
Too easy.
C.
I knew you would catch the hint in a jiffy. You only need time to read through the question. Question number 8.
A compound XFN is a fluoride of another hydrogen. And it's known that N is greater than 1. The highest peak in the mass spectrum is 222. Which of the following statement is incorrect? Single peak at सर फ्लोरीन का MR कितना होता
19.
है 19 19 B.
B. And why do you think A, C, and D are correct?
I just
First of
went
all,
for the
good,
option.
you're right.
I just went for option B and I calculated and it's wrong.
Good, good. That's a good perception. What do you think the compound is? Except N. The exact
And
formula would be.
chlorine. It could be
Since A
chlorine.
is not the answer, that really means N is equal to 5. Because we were supposed to find the incorrect statement, that means this is this. So I hope you understand this is this. And you already know this is not Br. Okay. So what is this? What is it then?
Iodine.
Iodine. Perfectly right. And this is IF5. So IF5 means the statement is correct. The statement is also correct. Let me tell you, I and F are both monoisotopic or monotopic. Monoisotopic or monotopic means something that has a single isotope. And let me tell you, fluorine and iodine both are one of those 46 elements of the periodic table that has a single isotope, single stable isotope, I mean. Okay, gold is one of them. These are the 2, 3 examples that we usually give to our students. Okay. So question number
Yes.
9.
Sir, I don't get option D.
CF3COOH fragments by sequential loss. Sequential loss means loss one after another of F atoms. You lose one F atom, then you lose another, then you lose another, like that.
All right, sir. A.
Actually, let me tell you, A is correct. I mean, it's a correct statement, which makes it an incorrect answer. CC bond cleavage do occur in this kind of system. In all kinds of systems, CC single bond is a cleavage that occurs during fragmentation. Fluorine is monoisotopic. This is also correct. COOH can be a fragmentine. D is the only one that can be considered as an answer.
Yes.
All right.
Yes, sir.
Okay. You can further work on CF3COOH and break out the peaks and think about 70 and 69, how those come as an answer. And you will understand what I'm talking about. Question number 10 is again about IR. And this finishes our topic for today. Any questions?